again, this time around we're trying to implement the coding stuff. I only have 10 minutes for this presentation, so I will try to make a quick rush. Still, batch assistants, I'm sure you still know me by the names. So, first of all, what do I need to generate? What is my project about? How am I going to define it? So this time around we are going in with the exploratory data analysis, and this means the data scientists have to analyze and investigate data sets and summarize their main characteristics, often employing data visualizing methods. It helps determine how best to manipulate the data. And for heat map analysis, as the main heading tonight, is the process of reviewing and analyzing heat map data to gather insights about a user interaction on the page. For instance, for this project I'm working on, I could not, of course, use maybe like I did not have my data set did not contain the numeric data, so I only try to use what I only have. So with this data set, you can see here with I'm having the audio form. I am sure you know this kind of spectrogram. So for the heat map, so that's the kind of heat map I use, because this is of course the heat map, and the higher tone, I mean this low, I think that's it. This high tone is represents the high volume, or the high volume, the loudness. This dim color is the one that represents the, of course, low tone. So the correlation matrix. What's a correlation matrix? Well, for a correlation matrix, you may not know it, but excuse me for that. Having some bit of well, I'll say that a correlation matrix, a correlation heat map is a heat map that shows a two-dimension correlation matrix between two discrete dimensions using colored cells. So for this case, you can see that the higher the tone, of course, the louder the sound, and the lower the tone, the lower the sound. So this is my correlation matrix. But in form of a confusion matrix. I'm sure that's what I was able to generate for my case. So for box spread, just to simplify this, because of this project, I had to it's hard to generate one since I'm limited to my data set with mostly audio, text, and only symbolic data types. So a box spread may be hard for me. So what are the feature independence plots? You can consider such a bar graph. For this graph was to measure, I will devote it to only define the highness. So the longest bar determines the highest tone, and the lowest one just the lowest tone. So that is it. Outplots, sorry, I'm rushing time. Outlier plots. Okay. With I having been limited to numeric data, currently can't generate the correlation between the different voices generated. So no outlier for me, but an outlier will simply be like this kind of format. You can see all of this data set. I mean the images you are seeing here. Just if anyone did physics, of course, you can know, or you remember one of the getting the line of benefit, best fit. So that's how you can get an outlier. So illustrations for the patterns of interest, I can give you that kind of a form. That is how you can see how it interprets the voices that were generated. So for the illustration of the time and space, so I can consider the graphs that were drawn or generated from the accuracy of my model as it was training and generating all that. So how did I explore and clean the data? So the data set was well explored by listening to various sounds that were gathered, and was cleaned by removing all bad sounds that would have given bad intent. So you can listen to this voice to show you one of the way we try to clean out our data. So you don't have time, but
No.
so that is it.
No.
Repeat point. So that's it. So how did we split the data into the training, validation, and test? Here data is split to half segments of the training, validation, and the training part. I mean the testing part. Sorry about that. Also for testing after training, of course. For example, I can show you after all the testing. You can see this image that this was the part of the training. It had 10 approaches. For 1 to 10, I only managed to capture 7. Sorry, that's all I could manage. But that's how it looks like after splitting the data. You get the one for training, one for testing. So I don't know that this one showed, but that's it. And these are the values that you will see: the loss, accuracy, and what have you. This is for only the training data. So the fitting the initial model of your choice for the diagram. Note that the diagram below is a test result generated after training the model. So this is how I've tried to fit any one of the models. So
No.
still, sorry, I used the same thing because I like this. So what are the hyperparameters? Well, hyperparameters, these ones, alright, should I say you should make research? Maybe. Okay. Hyperparameters. What are hyperparameters? Hyperparameters. Hyperparameters. The hyperparameters whose value is set before the learning process begins. So before you begin your learning process, those are the hyperparameters. A simple V, I had forgotten a lot of work. But you can consider this kind of model, these hyperparameters, the output, the shape, and these are the parameters. So there are how many params were there? Those are, I had all over 1.625611 params. So the trainable params were 1.62560 and the non-trainable were only 3. So those are one of the other parameters. How did I evaluate my set? Of course, the evaluation had to come from 1 to the 10 approaches, and this is the code how that I used. Thank you for coming. That was all. Have fun.